The main parts that make up a helicopter are the cabin, tail boom, tail rotor, main rotor, landing gear, transmission, and power plant. Main rotor systems. In the fully articulated rotor system, the blades are attached to the hub multiple times. The blades are hinged in a way that allows them to move up and down and fore and aft, and bearings provide for motion around the pitch change axis. Rotor systems using this type of arrangement typically have 3 or more blades. The hinge that allows the blades to move up and down is called the flap hinge, and movement around this hinge is called flap. The hinge that allows the blades to move fore and aft is called a drag or lag hinge. Movement around this hinge is called dragging, lead or lag, or hunting. These hinges and their associated movement are shown in figure. The main rotor head of a Eurocopter Model 725 is shown in figure, with the drag hinge and pitch change rods visible. The semi-rigid rotor system is used with a 2-blade main rotor. The blades are rigidly attached to the hub, with the hub and blades able to teeter like a seesaw. The teetering action allows the blades to flap, with one blade dropping down while the other blade rises. The blades are able to change pitch independently of each other. Bell Jet Ranger helicopter uses a semi-rigid rotor system, which is evident because of the way the rotor is tilted forward when the helicopter is in forward flight. With a rigid rotor system, the blades are not hinged for movement up and down, or flapping, or for movement fore and aft, or drag. The blades are able to move around the pitch change axis, with each blade being able to independently change its blade angle. The rigid rotor system uses blades that are very strong and yet flexible. They are flexible enough to bend when they need to, without the use of hinges or a teetering rotor, to compensate for the uneven lift that occurs in forward flight. Anti-torque systems. Any time a force is applied to make an object rotate, there will be equal force acting in the opposite direction. If the helicopter's main rotor system rotates clockwise when viewed from the top, the helicopter will try to rotate counterclockwise. One method that is used on a helicopter to counteract torque is to place a spinning set of blades at the end of the tail boom. These blades are called a tail rotor or anti-torque rotor, and their purpose is to create a force, or thrust that acts in the opposite direction of the way the helicopter is trying to rotate. The tail rotor force, in pounds, multiplied by the distance from the tail rotor to the main rotor, in feet, creates a torque in pound-feet that counteracts the main rotor torque. This is a 4-bladed tail rotor on Sikorsky HH-60 Pave Hawk helicopter. This tail rotor has open-tipped blades that are variable pitch, and the helicopter's anti-torque pedals that are positioned like rudder pedals on an airplane, control the amount of thrust they create. Some potential problems with this tail rotor system are, the spinning blades are deadly if someone walks into them. When the helicopter is in forward flight and a vertical fin may be in use to counteract torque, the tail rotor robs engine power and creates drag. Another form of anti-torque system is the fenestron or fan-in-tail design. This system uses a series of rotating blades shrouded within a vertical tail. Because the blades are located within a circular duct, they are less likely to come into contact with people or objects. A third method of counteracting the torque of the helicopter's main rotor is a technique called the no-tail rotor system or notor. This system uses a high volume of air at low pressure, which comes from a fan driven by the helicopter's engine. The fan forces air into the tail boom, where a portion of it exits out of slots on the right side of the boom and, in conjunction with the main rotor downwash, creates a phenomenon called the Coanda effect. The air coming out of the slots on the right side of the boom causes a higher velocity, and therefore lower pressure, on that side of the boom. The higher pressure on the left side of the boom creates the primary force that counteracts the torque of the main rotor. The remainder of the air travels back to a controllable rotating nozzle in the helicopter's tail. The air exits the nozzle at a high velocity, and creates an additional force, or thrust, that helps counteracts the torque of the main rotor. For helicopters with two main rotors, such as the Chinook that has a main rotor at each end, no anti-torque rotor is needed. For this type of helicopter, the two main rotors turn in opposite directions, and each one cancels out the torque of the other. Thanks for watching.